Yo, 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 what's up, what's up? Welcome back. Today we're working on visualizing clustering algorithms. So, background info here. We're working on this like QR code decoder, and we have like several situations now as we're moving into like working with real data. We want to like work with real data, and there's like noise in real data, right? So there's like several situations where we're going to end up with a bunch of samples, and we want to use those samples to get some useful data, right? So some examples are, we have this like finder. These are like finder codes in the corner. And one of the things that we want to do is we want to look for like these green segments. So what we do is we walk these like scan lines left to right, and we get these like red candidates, these blue candidates for where we think the finders are. Then we like look for areas where their red and blue intersect. And in our case, we're getting like 4 samples in this case. What I'm worried about is that there might be like samples that end up in other areas. And so we need to find a way to like take these samples, find the 3 areas of interest, and only look at those. There's like other things where this concept is going to be useful. So one of the other things we do is we like walk this timing pattern. So we go like white, dark, white, dark, white, dark, white, dark, and we count how many times that change happens. And what we might end up seeing is we might see like some noise, and we might end up with some samples that are out of like the main area, and we want to be able to like discard those outliers. You know, there's other scenarios where this comes in handy, and so what I want to do is I want to like look at these concepts and how do we like take these clumps of data and like turn them into like actual clumps in code, and that's going to be useful, right? Yeah. So what we've got so far is we built up this visualization in Zig where we have a web server, we generate a bunch of points, and when we refresh, we get a new random set of points. And today we want to actually start doing something with them. One sec. Okay, better. Sorry, I was testing listening to myself as I was talking, and I just can't fucking think when I'm doing that. I wanted to make sure that like my sound was okay, because sometimes I peak, but then like there's like a little bit of a delay, so I'm just like hearing myself like 200 milliseconds later, and my brain just like can't fucking handle it. So anyways, that's where we're at. So next up is we want to like try a clustering algorithm, and so today I think we're looking at hierarchical clustering, which should be like the simplest of all of them. Or like, sorry, I shouldn't say simplest of all of them. This is like what I would do if I were to just try to do like without looking anything up. This is just what I would have come up with. And it's like you just sort your points by distance from each other, and you just take the the two closest to each other, and you slam them together, and then you take the next 2 closest together, and you slam them together, and eventually you stop, and you'll be at the point where you have like some clusters, and you just have to like set some threshold of like where you want to stop, some criteria. I don't know what that's going to be yet, but we'll figure it out. So I think what we're going to do, plan of action. Stub out visualization of clusters. So right now we just show red dots. We need to like have some sort of data format that the server can send to the client to like group those in colors by cluster or something. Once we have that, then we can like implement hierarchical clustering. And then this like data visualization kind of like sucks because we're doing like uniform distributions of X and Y. We should end up with clumps so that we can actually test the actual clustering logic. And then from there, we'll see. There's like 2 ways to do hierarchical clustering. There's like you start at the bottom and you like group stuff that are close together, but there's also this like top-down approach where you start with one big clump and you keep splitting it up, and this seems like a little more complicated. So at the very probably if we run out of stuff to do, this is where we'll end up, but I don't really know if we're going to end up running out of stuff to do. We will see. Okay. So I did a little bit of cleanup yesterday and updated to Zig 0.12.0. So if you were here yesterday, things will look a little different, but it's not too bad. It's all like the same code, just kind of like shuffled around a little bit. Okay, so probably right now we have a set of points. Let's see. Yeah, what we do is maybe we look at the client first. Basically, when we start up our thing, we just have like a little HTML canvas. We say, hey, could we get our points? And then we draw the points. Simple. Now we probably want to ask for like the groupings as well. And I think there's probably no reason to try to get like fancy with our API and say like, well, here are the points, and then we have another API to get like their sorting and stuff. You know, like we don't. It's like all local. We can just get like one like data. We can just ask for everything at once. And so here we'll call this. We can still call the concept point data. Maybe we'll even just leave the API the same, and we'll just not return an array anymore. I guess we will return something that's probably like what's in here. We'll have like points, which is going to be our array of like x3, y4. You know, these are going to be like our points. And then we can have our clusters. And probably what makes sense here is just a double nested array. So we'll have like, you know, points 1, 2, and 4 are in this group. Points 5, 9, and 11 are in this group. And we'll just go by like indices. I think that's fine. That's fine. Oopsies, I meant to do ... Which kind of means that like our like internal abstraction, like probably what we're gonna end up doing is, I'm imagining that we're gonna have like our little set of points on the screen, right? And I'm kind of imagining like a little like step button, and I imagine you like slam this button, and every time you click it, maybe you go like one more iteration forwards, and you refetch the data and you recolor and stuff. And so like the kind of the way I've structured it is that we have like this like app, right? And he has his points. And so probably he's also going to want to store his clusters. And so this clusters is going to be something that's like dynamic in some way. And if it's going to be like this, probably in Zig, it's easier to split out a struct for clusters. I think, because how to say this, like managing the heap allocation of two dynamic, like double nested vectors is just a kind of a pain, because you have to like actually remember to free every single one, because we're in C Zig land, not C++ Rust RAII land. So he's gonna have his like clusters here, which is going to be std array list of std array list of usizes for indices into the points array. And we'll just have a function dinit here who takes self as a mutable pointer to clusters, and he's going to call well, what if we just shove all this shit in an arena? That makes my life easier. Arena allocator, and then we can just say self arena d in it, and I don't have to worry about it. I guess probably are we going to ever like be removing stuff from clusters? We might be, but I guess we'll kind of see how the like API moves as we go, and we're gonna have to initialize this thing with some sort of allocator. And he's gonna return void. No, he's going to return clusters. A clusters. That's confusing, but is what it is. And we're going to have to make an arena allocator here. So we'll say our arena is std heap arena allocator initialized with the alloc we pass in. We'll call this child alloc here so that we can use it or else, and then we can say const alloc is equal to arena allocator. That way I won't accidentally use the wrong one. Now we have to make our cluster list. So std array list, that's the parent alloc. I guess it depends on which way you think. I think that I have a structure arena allocator, and in him there is a member called allocator. And so, from my perspective, he is the child of my arena. The arena holds another allocator underneath. But from you're kind of saying, isn't that the parent? Because you're saying like, well, this guy actually does the allocations, and the guy inside is like, I say like, hey, mommy, could you get me some memory? Right? That's kind of like what you're indicating, right? Like you would call it a parent that way. I'm kind of saying like, I'm the parent. I am my allocator. Child, give me some memory. Like, I'm ordering versus asking. You know what I mean? I think it's like, you could call it either way, and I think it'd be fine. I think that they call them children in here. Yeah, in the Iranian allocator, he calls it a child. So I'm going to call it that way as well. But I see your argument. Okay. This guy's going to be initialized with the allocator. And we'll call this clusters. And then we return our arena is equal to arena, and our clusters is equal to clusters. Okay. So we're going to generate some points, and then let's like make some clusters. So I guess we'll have some functions like add to cluster, and we're going to take in ourself, and we're going to take in a cluster ID and a point ID. And we are just going to say self clusters cluster ID dot something const or var const cluster is equal to a pointer to this guy. So this is var cluster, maybe const cluster. I don't know what they want. I know that like the new Zig, they get mad if I have non-const things that aren't used as non-const. But here I want like a pointer to the thing inside, and so the pointer is constant, but like the thing I'm pointing to is not. And I think that's probably what they want. And then we'll just say cluster dot append. We probably have to try here, and we append the point ID. Easy. Yep. Simple. And then probably we're going to want to like create a cluster. So add cluster, and this is just going to be clusters, and we are going to return one. So this could fail, and then we will return the cluster ID in response. So we'll just say try self clusters append, and then we append a new thing with the same allocator under the hood. So we'll say array list. This is going to be an array list of use sizes initialized with our arena allocator. Okay, I think that makes sense. Okay, so all of that to get us to the point where we can have clusters is equal to clusters. And when we initialize our application, we will just say clusters is equal to a clusters initialized with our allocator. And I think we're chilling. So I guess we also want to like, for now, since we're just trying to test, let's just like make some clusters to see how it feels. So we'll say var clusters equal to this, and then clusters dot add cluster. We'll just add a few. Cluster, dude, I don't know, this word looks like garbage to me. That doesn't look like a real word. There's something, but like, I think my brain's doing like some sort of like shape recognition on the shape of the word. It just doesn't like it. Because like that is how it's spelled. It's just like, I don't like this like CL, yeah, it looks funny to me. I don't know why. Okay. So let's add some points. So add to cluster. We're gonna add to cluster 0. Maybe we'll just make 3 sets, and then we'll kind of just put them all in. And since the points are kind of like uniformly randomly distributed, this will end up with just kind of uniformly distributed speckles on the screen, I think. If I go like 4 points items, point. No, we don't even need to look at the points. We just need to go from the ranges, because we're going by ID. So 0 to points items len. We just add point. And we'll do, let's see. We'll say const cluster ID is equal to points items len. No, sorry, point over clusters items. Maybe we'll just call len here. Do I want to just... Do I want to like use the thing directly? I guess I do. Clusters.clusters dot len. Here we go. And then here I will push into the cluster ID with my point. Okay. So now we should end up with 3 sets of clusters. And we can, I guess we're just exposing this as a public member variable, which is kind of gross, but fine for now. It doesn't fucking matter. In the future, I can decide to abstract that if I want to. Okay. So now, when we serialize this stuff, we're gonna say, hey, I'm an object, but let's start with, well, actually, I don't know what the format of this thing is right now, to be honest. Can we look at what comes up? I don't know if it's wrapped in like, if it's like one big object, then array. No, it's just one big array. I know it's just one big array because I didn't name anything. Okay, so here we're going to say, let's make a new object. And at the end, we have to end the object. I literally gave you the follow because you decide to abstract later. You're doing the Lord's work. What? Okay, wait, let's see. Are you saying that you are really against the concept of early abstractions in general, or you just think it's boring and you don't want to watch it right now? Because sometimes I do think the abstraction is useful. I just have to decide. Like, it feels better to me. Like, 1, we get through more faster on stream if I don't abstract now. 2, it feels nicer to me to like figure it out later. I don't know what it's going to look like. Premature abstraction of the root of all evil. Yeah. Focus on premature. Dude. Yeah, I agree. It is pretty awful sometimes. Because I think that like anytime I sit down and try to plan something up front, I'm wrong. It's different when you're in a big code base, but even then, like my process of like when you like build out those like UML diagrams, I don't know if anybody uses UML diagrams anymore. Those are old school. But like when you're like writing them out, I can't write them out without like trying it. And then it's like by the time I've tried it and made the plan, it's like, I guess I will just pretend that I didn't do this, and then I can submit my plan for review and then just like immediately shift it out from yeah, anyways. Okay, so we have an object, and we are going to begin something. So we're going to say we want to write the thing points. So try JSON writer begin or object field, and we just say, hey, where are points? Then we start writing the value, and then we end, I guess here we end the array. And so here we should just be able to say, let's make a new object, I think. Or sorry, a new field. And so this is clusters. And then we do the same thing where we start and end an array. And in here, we just iterate our clusters now. So here we'll say for clusters, so which means that here we need to take in clusters as const. What do we want this as? I guess this isn't technically, we don't technically have like a 2D slice at all. So this is going to be some like fucked up weird type where this is like a slice of array lists of usize, I guess. I'll probably come back to this. I don't really like this. We might end up abstracting the inner layer a little bit, but for now we'll just do this. And then we can say for clusters, we look at each cluster. For the cluster, we look at each point. And then for each point, we just write the point. And then at the end of this, we have to end the array, which we did, and we end the object. I'm not really sure that that's right, but we can always just run it and see how it fucks up. App points clusters items. Okay, so add cluster, errors ignored. UML is taught in uni for CS. Okay, interesting. It feels to me like that sentiment of like drawing out your object hierarchy. It feels kind of like it's going away to me. But maybe not. Or maybe school takes a while to catch up. As you might want to think about my use cases when I want to plan ahead in order to avoid noisy services, flow charts, blah, blah, blah. Yeah. It is a very helpful thing. I used this a lot when I was reviewing code frequently. Just the ability to just like bang out a like, okay, so this guy put in this object, like object A, and then like this like is related to like object B by, I think you do like an arrow or something. Like just being able to like draw these out really quick, and then when they're in code, you can just like slap them around. Doesn't really matter, but it is useful when you're trying to like build up a mental map that you don't have like a good one. So I agree. I mean, I still use them, but yeah, I don't like pre-plan too hard. App.zig line 28. So what's complaining here? Oh, I forgot to return the thing. So we need to return self clusters items len here. -1. The thing we just pushed. Return the index of the cluster. And then all of these guys need to ignore the error because we're kind of just like assuming the order underneath the hood. So it's fine. We know that it's 0, 1, 2, but maybe in the future we won't know. And there's no len in clusters, clusters, items, len. Gross. Absolutely disgusting. It's fine. Add to cluster has to have a try. And we fucked up here. We forgot to write items somewhere. No field name clusters instruct array list. Oh, yeah. I typed the wrong thing here. It should be app clusters items like this. Okay. And we're getting somewhere. We're getting closer. No field items in app clusters because it's app clusters items. Yeah, this is gonna have to change. This is fucked. Address violation. Cool. So at add to cluster, when we append to our clusters, he doesn't like that for some reason. That's surprising. So what's going on there? We create our clusters. We initialize with an allocator. We add our clusters. And this is at add. This is at add cluster, not even add to clusters. This is an add cluster at line 58. So this is the first add cluster. He's just like complaining. What's he even got to complain about? We append address violation. Oh, address violation on the allocation itself. That's surprising. Whoa. What's going on there? What is going on there? Address out of range. Segmentation fault. Wow, this is fun. Look at it. This is fun. GDB zig out clustering viz. I must be using just like the arena totally wrong or something. So let's look at okay. Let's look at frame 12. So we have like self arena. And we have this like child allocator at this address. And so let's just make sure that that is what's being called here. We're being called with allocator at, this is somewhere else. Oh, but this is in the arena allocator itself. Okay, so that's piece of info. So here we're in, where is this? List 0. So we're at like line like 80 something. So we are in the, what like file are we in? This must be the arena allocate. This is either allocator or arena allocator. I wish it told me. Oh, it does. It does. We're in. Oh no, this guy tells me a file line number, but this guy does not, which is annoying. But I guess we can go to frame 1. And we know that we are in allocator, and in frame 1, we are in resize, which is calling the vtable implementation. So our vtable is going to have function pointers to the arena implementation, I think. Unless we've already gone through the arena side and we're now... Because what's going to happen is like the arena is going to call the underlying allocator. I don't know which one we're in. Oh, but I guess we can find out pretty easily. If we go to frame 2, we can look at p self. So self is 2e58. So we can just, not self, no, so we want self dot, oh. Okay, so we're in the arena at frame 2. Frame 1, we are calling the resize function of the allocator, and then frame 0, we're here. I feel like I'm missing something really obvious. I did not know how awesome Zig is to work with. Well, I mean, is this a joke? Because we're just like fucking losing our minds with these arenas? Okay, so we are... No, seriously. Yeah, I mean, I would say that so far it feels like I would recommend it if it was a little more stable. I like, you know, my feel is like, at work, no shot am I ever pushing Rust, right? Because I don't want to be the guy that people hate when they're like, oh my god, lifetime's immutable references, like... So I don't think Rust is ever going to be something that I push unless everybody else is already on board, right? Maybe you could start a company and push Rust because you would only just hire people that like it already. But Zig, I feel like you could actually like transition someone off C++ into, and it would just be better. Why did I leave GDB? I felt like I wanted to stay in there. We'll just run it again because we segfault immediately. Ooh, you see the issue. Do I want the spoiler? Do I want the spoiler? Context 7ff2e58. It's not the same arena. Should be. Is it not? I created the arena here. I assign it here. Then I use the arena's allocator here. I'm pretty sure it is the same arena. Am I high? I think that probably what's happening is like maybe this allocator is he assigns pointer to self. I'm not storing the arena I created. Am I high? Arena equals arena. I'm pretty sure I am, unless... Like, huh? Here? Arena equals arena? That's the concrete type. But like, so I think that I understand that I'm like creating an allocator twice. But I thought that should be fine because this allocator should be identical every time, right? Self pointer gets this pointer to the... Oh. Oh, I see. Oh, what the fuck? Okay, so when I construct this allocator, I get a pointer to this arena. And this arena then gets moved into the return. And so, like, this allocator that I initialized the clusters with is no longer valid. Ew. Ew, 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 ew. Store the wrapped type? I don't think I understand what you're saying. Like, I think what I have to do is I have to, like... Here, let me double check this. Pointer is equal to self. So yeah, this guy... Like, it's almost like I have to heap allocate this guy just so he doesn't fucking move. No, that's still... Like, storing arena of stood mem allocator would still be invalid. Because what's happening here is this guy is using this pointer to the arena. And so this arena would have to either... We would either have to pass in the arena here... on init and like store it somewhere else, or heap allocate the arena. So I think I'm just gonna do that. So, oh, that's so shit. I think I've made this mistake somewhere else, actually. Where have I made this? Was it here? Yeah, I've made this mistake on my argument parser, but it's just not a problem because on Linux, the argument parser doesn't actually allocate it. Pass the GPA, make the arena, store the wrapped arena. I'm pretty sure that doesn't work. Right? Am I high? Right? If I take this is my GPA here, make the arena, and I store the but why? Right? Because the reason that it's segfaulting is because I call this allocator with the pointer that's passed in, right? So when I call I might be missing something. So when I call this allocator's when I call his alloc, wherever that is, he eventually is going to use the pointer that is stored inside the allocator, right? We're going to use this field here. And this field is pointing to this stack allocated thing, who's just going to go away. Right? Am I high? Right? Like, yeah, we can try it, right? We can just... But also, like, you either store a pointer to the concrete type you made. I either store or you store the interface. But I'm saying that if I make the arena on the stack in this function, and then I store the interface, it's still going to point to invalid memory. I mean, this is like easily provable. Let's just fucking prove it. Okay. Like pub function main void. We're going to have some function. Make allocator. Who's going to return an allocator? So stud mem allocator. Stud is equal to import stud. And here, if we were to do something like stud heap arena allocator, init with GPA alloc, and I'll just make this global for now. Fuck it, we'll pass it in. And then we returned const arena is equal to this arena dot allocator, right? You're saying to do this, I'm pretty sure is what you're essentially saying. So then I can say like var GPA is equal to stud heap general purpose allocator. I pass in an empty config and then I can initialize him and then I say my alloc is a stud heap GPA dot allocator, and then my like arena is the make alloc, right? You're saying this is essentially the same thing, right? You're saying store the interface, not the or a pointer to the concrete type. I'm saying that this guy is fucked. We can like stud debug print any. I guess we can probably just do like arena alloc, and this will crash. So let's say that let's like make some i32s. Let's make some i32s. Var i32s is equal to this. And then stud debug print. We'll print the i32s. Const. So if we zig run source test zig, he's gonna be mad because we need to say const allocator is equal to stud mem allocator. Local variables never mutated, so throw a little const on here. Expected type this found that. Whoa, 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 whoa. Expected type. Oh, I see. Here, this needs to be var. Okay. So That is compiling, but I'm like pretty goddamn sure this is valid. So let's do something else where we make a second function. Clobber my fucking stack. And in here, I'm just going to make a bunch of U8s. I guess I don't really know how much Zig is going to optimize, but I'm pretty sure that if I say like ASDF is a bunch of U8s. So this here, I'm just going to say like, how do you do this? You take this, and you write U8, and then you write this times 1,000. And then discard ASDF. And then here, I say, clobber my fucking stack. Hopefully, we'll see that this actually has an effect. Expected type U size, found type. Oh, it's the other way around. It's this bracket like this. There we go. Incompatible types 1 U8 and comp time int. Oh, it's double star. Huh. Okay, std debug print. I'm still not convinced. But it is not doing what I expected. Can I get like the address of ASDF? Let's just see what this is. No field pointer. Maybe it's just print address of ASDF. Ah! Here we go. So, general protection exception, no address available. So this is coming from Alec. Yep. Yeah. See, okay, this is what I was fucking talking about. Okay, so probably Zig was being too clever and wasn't like clobbering my stack unless I printed the address here. But I'm pretty sure what's happening. Wait, what the fuck is being printed here? Oh, it's this print here. Let's do I32's. Can we print like I32's len or something instead? Just to double check. Where is this coming from? I'm not trying to print that. Is it because I'm printing this? Oh, I want to print something like this dot pointer. Is that how I get the fucking... I just want to like print the address. Do I have to write P here? Oh my god, oh, this was supposed to be a quick proof. How do I print address of? Pointer to many, output optional value, output error union, output address. Fuck, it's a star. I read a star. Write the star of ASDF, please. Ampersand ASDF. Okay, here we go. And so here I'm seeing this guy, and maybe we'll also print the address of the arena. Okay, so this isn't doing what I thought, but I still am segfaulting here, which is what I expected, right? Like, if you look at the source of array list, it stores the interface by value. I like get that. I'm saying that you have like array list stores allocator, right? Sure. Allocator stores vtable. That's fine. Allocator stores pointer to parent allocator. Right? So when I call like on this allocator, alloc.alloc, this goes from my allocator. He looks at his vtable, which is fine, which is gonna have like this like alloc field, which is gonna go to gpa.alloc. That's all fine. Nothing's a problem there. But this function takes in a context pointer, and that context comes from allocator dot pointer. So he's gonna call this function with the pointer to the parent thing. And if that parent thing is gone because I made it on the stack here, it's like, ruh-roh, that thing doesn't exist anymore. Arena instance stores that, not the interface. But the arena, like, this is the arena instance. There is no, like, global variable. This is, like, in the function, right? Right, otherwise, if this wasn't the problem, then why would I be segfaulting here? Right? Like, the reason I'm segfaulting is because I need to take this arena, and he needs to be, like, valid for the lifetime of the allocator that you're using. So if I take this, and I shove it down here, and instead I take var alloc is equal to arena allocator, like this, so we'll call this arena instance, and we'll call this arena, just so that the names match up. This shouldn't segfault anymore. Fuck off. We'll comment out this function. Right, this doesn't segfault anymore because this arena is valid while the allocator, like the instance is valid. The allocator is storing a pointer. So I'm pretty sure that, like, I understand the problem. And so if we go back into my app here, this guy, like, this is just not valid. What we need to, I think we should still store the arena, but we just need to make sure that the arena, since we're giving out pointers to this guy, just doesn't move. And so we can just do that by saying, like, child alloc dot, how do we make, like, one function? There's allocate, but I want there's one that's like, give me a bunch of stuff, and there's one that's like, give me one thing. Zig standard, I want 0, 12, and then I want to look for allocator. Allocator. Hello, allocator. Where the fuck stood maps? Where's my allocator? Here you go. So there's alloc, which will give me a slice, but I want not a slice. Create. That's what I want. So here, if I just say arena equals child alloc create stood heap so I want to do like var arena is equal stood heap create. No, what am I talking about? Child alloc create stood heap arena allocator. And then now, oh, but when I initialize this guy, he's going to call some stuff and then give me back this. So I guess I create him, then mem copy him in. Can I, like, is there a function that's like, create this thing, but with these fields already? Like, just allocate me this exact thing, just move him to the heap. I just want to move my guy to the heap. Alloc with options. This doesn't look like what I want. Yeah, nothing crazy. So I guess I just call alloc, create my arena, then say std mem, or maybe I just say arena dereferenced is equal to this. Yes, 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 that sounds right. But probably this equals operator won't work. I don't really know if you can do struct assignment like that in this language. You might be able to. And then I think that this will work. We'll see. Zig build. So yeah, cannot dereference non-pointer type this because I have to try this allocation here, which means that this can fail, which means that this guy has to try wherever we call him, which is here. Oh, that's funny. This is broken in another way as well. But that's just a minor bug. Doesn't really matter. Okay. So now we store a pointer. And then when we de-init, we have to first de-init the arena, then free it. So we'll say const alloc is equal to arena self arena child allocator. We can like kind of yoink this guy out. We can deinitialize him, and then alloc.dinit destroy. Is it destroy or free? Destroy. Yeah. Okay, panic, index out of bounds, index 3, length 3. So this should be -1, I guess. No. Point divided by the length. Oh, here we'll just, then we have to make sure that this ends up modulo this thing. Hello, are you cool? Yeah, super cool, super popular, super famous. Definitely cool. Okay, so no more segfault. That's good. If I refresh this guy, let's see what we get out of this points response. Okay then. Yeah, perfect. So clusters, I wanted a okay, then it'll follow as a result of that. That's so funny. So clusters here is supposed to be double nested array. He's not, so we fucked that up somehow. Also, when I control C, we're getting some leaks coming out of clusters in it. Probably because in our app D in it, we forgot to free our clusters. So let's just double check that one. Hit refresh a couple times and then hit control C. No leaks. We're chilling. Super chilling. Okay. What was I doing? I was fixing the cluster format in the server. 0 Kelvin, if you will. Super cool. So here it was that before every cluster, we need to make another array inside. Like this. And now, if we look at our data that we get, refresh, it should be, we get points, which is an array of object points, and clusters, we have our 3 clusters with our points inside. Dude, that took so fucking long because we got distracted by allocator problems. But on the bright side, that probably won't happen again, ever, right? We've kind of like solved that problem, and now we don't have to think about it again, which is kind of nice. Kind of nice. Okay. So let's rerun this guy. But I want to do it with, I've got this setup where it embeds the index, like the HTML stuff in the application, but I can like pass in this like argument that says, hey, could you like actually serve it from this path? And then it will let me edit my JavaScript on the fly, which is kind of nice. So here, let's just start by saying point stop. We'll say here, this is not points anymore. This is like data. Points is now data.points, I think. I think that's how object parsing is done. Yeah, that's fine. So we refresh, we're chilling. And then let's, for each point, we're going to want to look it up in the cluster. So probably actually what we're going to do is we're going to iterate our clusters first. I think that makes sense. And we'll pick a color for each cluster. So I guess we'll say like const color is equal to red, green, blue, right? And then down here, we'll say that our with this like JavaScript style iteration, how am I supposed to get like indexes out? JavaScript array iteration with indices. Oh, I guess I just do for var I or cluster ID equals 0, cluster ID less than data clusters length in this language. Cluster ID plus plus. Is this how I'm supposed to iterate in Java? Let me say for, well, we'll see. SEAD, nope. that's Zig. Console log. I just want to make sure that I've got like cluster ID. Is this like how you do this? Is this supposed to be let probably? Maybe. Okay, 0, 1, 2, chillin'. So then we can say for point of So here we're going to iterate by cluster. So data clusters cluster ID. And then when I refresh here, we break. Super cool. Probably because, well, I'm surprised that it's not yelling at me harder. Why is it just doing nothing? For point of data clusters cluster ID. Console log. This. This is fine. Okay. Yeah. So why am I not getting, like, a point in here? Oh, I am. This is a point ID. And then here we need to say const point is equal to data points point ID, I guess. There, we're back to drawing the points. Dude, fucking JavaScript, man. Like, it's probably because, like, point.x, it's probably we're calling ctx.arc with just, like, undefined because point was a number. And it's just, like, fucking yell at me. What are you doing just, like, rendering nothing? What's wrong with you? That's insane behavior. Oh, okay. So here, let's set the color. So this is going to be, the colors indexed by the cluster ID mod colors length. JavaScript is like that friend who complains behind your back. That's so funny. There we go. Okay. So now we are, yeah, we're coloring by cluster. Fucking finally. Fucking finally. Gross. Absolutely disgusting. But it's okay. We'll live. So we'll commit -m and say group points into clusters. Okay. And now we actually have to do some clustering. So I guess that's kind of live somewhere. That's a statement. Probably in like source. Let's just go into the app for now. And here we'll say that we have some sort of like, what's this thing called? It's not hierarchical clustering, has two modes. Let's make sure we get it right. Agglomerative. I've never heard this word in my life. Pronunciation. They don't have a little, do I have to do this on Google to get the little speaker? I know that, like, isn't it built in here? Define. Wow, is the word so fucked that it's, like, not even, I'll go see.
Agglomeration.
Agglomeration? Oh, agglomerative and agglomeration are different. How do I get back to
agglomerative? Agglomerative. Agglomerative.
Huh. I feel like I've heard, like, aggregate. Anyways, it doesn't fucking matter. It doesn't fucking matter. It's just a word I've never heard in my life before, but that's okay. Agglomerative clusterer is a struct. And he's gonna have, how do you pronounce agglomeration? It shows the widget. Now I'm curious. Does it show on DuckDuckGo? No, but probably on Google it does. Oh yeah. I don't know why, but it's them not using the like the funny letters for pronunciation, but just try to sound it out like a fucking idiot is so funny. I haven't seen that, but that's hilarious.
Agglomeration.
Oh nice, they get the little voice guy going here too.
Agglomeration.
The little mouth movements. It's kind of neat. Okay. So this Wikipedia page, he's not like super informative on like, you know, sometimes you look up algorithms on Wikipedia and they give you like a step-by-step. This one's kind of just like, find the close ones and stick them together. So we can just kind of do that however the fuck we want. So what are we going to want out of this? We're going to want to visualize. Not using IPA for pronunciation makes me puke. But to be fair, I'm assuming IPA is the squiggly funny letters. nobody knows what those mean, right? Like, it's more accurate, but surely you can't actually read those. So he's gonna probably. Are we gonna store a reference to the clusters here? That probably makes sense, right? So here we'll store a clusters reference. It's so easy though. Schools should actually teach it. I'd agree with that. Well, I don't know that it's easy, but I do agree that schools should teach it if it is easy. He's also gonna have like points. There's gonna be a pointer to some points. Probably const. And let's just like kind of step into the algorithm first, and then we'll see how it goes. So we want to like be able to do one step at a time so that we can like inspect state in between, slam the next button, you know, get moving and grooving. So I guess his return is going to be nothing. And he's just going to update some internal state. And his internal state is actually pointers to like the app state, so maybe it's fine to just do it this way. Maybe we don't need anything, I mean. We're probably going to need some sort of like tracking data for distances between points. For now, we're just going to do like the dumb stupid thing and do an n squared search, I think, where we like look at each point and its distance to every other point. You could probably get a little clever and like tile your image, your space a little bit, so that you don't have to do n squared. But right, like if you were to like have your things like this, you could like break it up into tiles, and then if your points in here, you just like wouldn't scan points from here or here, but you would look inside. You would probably have to do some like overlap shit so that every point you like how do I say this? If you have like some radius, every point has the full radius that you're looking for inside. And then you would like probably scale up where you like start with small tiles and get bigger and bigger or something. But I'm not going to deal with that right now. Also, that doesn't solve the case where if you have 99% of your points in one small area, you still basically would like degrade to n squared there. So you could probably then limit it by like saying like I'm only going like if I see a lot of points in one tiny box, like we'll just immediately fucking slurp those up. But for now we'll just do this stupid fucking thing, and we will just say distances, and I'm gonna want these to be sorted, and maybe I want a heap. Maybe I just want to get maybe I can get away with an array. I could probably get away with an array. I think I'm fine with that. So this is going to be an array list that is kind of like storing point pairs. Probably. Right, so here is going to say like I have A, which is going to be like a index into the point array. B is another index into the point array. And then we'll store the distance. Which I guess we'll just store in float space. That's fine, yeah, I'm fine with that. Okay. So this is going to be an array list of point pairs. And we will just first allocate this array. So on initialization, yeah, let's say that like on initialization, we just calculate the distance between every single point and every other point. That's fine. We can live with that. Then we will say, how many points have we looked at? We don't have to do that because we can just sort them backwards. If we just sort them backwards, then we can pop them as we go. And we never have to look at them again. Yeah, that works for me. So we'll say distances pop or null. I guess we'll just say if distances items len is less than 1, we'll just return. Nothing to do. Everything is clustered into one massive cluster at this point, probably. Then we can safely not do this check here. We just say fucking pop me a thing. So here we'll say point pair is equal to this. We are gonna want to like find the cluster, figure out if any of our clusters have any of these points. So maybe we will write a little function cluster for cluster containing point. And he will return an optional usize. And we have to take in a point. Okay, and so we'll just walk our clusters. Let's see. So we're going to go for each of our clusters. We're going to say, is the point in there? Yeah. So we're going to say for points cluster items, and we'll call this a cluster point. And then we say if cluster point is equal to point ID, we return cluster index. So here we need to say like this, cluster ID, and then we return null here otherwise. Okay. This is stupid in a lot of ways, right? Maybe we should be using sets so that it's easy to do lookup. But for now, who fucking cares? You know? We can always do that later if it becomes a problem. So we can say cluster containing point. We'll look at A and we'll look at B. Yep. So const A cluster is this one, B cluster is this one. And actually, because of the way that we're supposed to set this up, we're supposed to start with a cluster per point at the beginning. So here we should probably be able to assume that these are both set. And so now we just say, we just need to merge clusters. So merge cluster A and cluster B. That seems reasonable. So now we'll just say function merge, and we'll take A cluster ID, which is a usize, and B, which is a usize. And maybe we can error out here. Maybe, not really sure. And I guess what we'll just do is we'll take all of the items in B and stick them in A. So we'll say var A cluster is equal to this. Maybe we need to do a pointer here. B cluster is this. So maybe we'll call this A ID and B ID so that we can call them A and B here where that makes more sense. So delete the end. And now we do something like for B items, B point, we try A dot append B point. These can probably be const. Yep. And then here, we then have to delete B. So we can probably, we can do a swap and pop, assuming that nobody's storing cluster IDs anywhere. And I think that should be fine. I guess we probably want some form of like coherence between the colors of the cluster, right? As we like progress through our cluster, our algorithm, we don't want like one cluster just completely change colors. So instead of popping and swapping, we'll just clear cluster B, I think. So is there like an array list clear? Clear and free. Invalidates all element. Yeah, that's what I want. And then we'll have like an empty cluster, but that's okay. I'm okay with that. For now. Okay. So now all we have to do is when we initialize this thing, he's going to take in, I guess, an allocator. because he's going to make our distance list. And he is going to... He also has to take in points and clusters. And here we just say cell distances is going to be a new array list. Array list of point pairs. Initialize their allocator. Great. We are going to resize him to points length squared. Because we're going to calculate the distance between every single point and every other point. Probably it's more like capacity. How do I adjust the capacity on the fly? Init capacity, sure. Can I like set capacity after? I mean, I can just call it init capacity, but now I'm just kind of fucking curious. Capacity. Resize, shrink and free. Ensure total capacity. Yeah, I guess it's this. Ensure total capacity. So here we say, hey, this is how many things we expect to have in here. I guess technically -1. Right, because we're not going to minus something. Because we're not going to compare an item with itself. So there's like a diagonal somewhere that's getting removed, but it's just fine. It doesn't fucking matter. We'll overallocate a little bit, who cares? Okay, so 4 points. Maybe we'll do 0 points len. I kind of like that better. And we'll do a second loop inside. Wee woo, n squared. It's okay. We'll live. We don't bother with I equals j. Okay. But otherwise we do. So here we're just going to say distances append. We have to try. We could fail. Because allocations are not perfect. And I guess we'll just make a point pair. So A is equal to I, B is equal to J, and distance is equal to distance. And here we're gonna have to do some sort of like const AF is going to be points I as an F32 and BF is going to be points J as an I32, and then I'm actually going to use distance squared metric here because all we have to do is sort them, and then I can just do oh wait, this is points is a structure. So here we have to do AF XF. Here we go. So this is going to be .x, .y. Maybe we'll just do this. AX, AY, BX, BY, like this. Nice. Okay, here we go. So doing distance squared here lets me just do like, because you have to do like Euclidean distance. So AX minus BX, we'll call this X dist is AX minus BX. And Y dist is AY minus BY. And then distance is now X dist squared plus Y dist squared. Right, because we're doing 2 dimensions, little Pythagoras, A squared plus B squared equals C squared, and we just don't square root C because it doesn't fucking matter. Because we don't really care about the actual distance, just sorting them. I think. Maybe. So now at the end of this, we have to sort the distances. We could insertion sort, but fuck that noise. Sort. And we sort a block. Sensible or stable in safe place sort. Is there unstable in safe place sort? Yeah, hell yeah. Who cares about fucking stability, am I right? Okay, so we have our type, which is going to be a point pair. Items, which is distances, items. And the context is any type. I think we can just get away with a void here. And we need a sorting function. So here, I guess we'll just make a little less than. And he's going to take in A, which is going to be a point pair, and B is going to be a point pair. And he's going to return something. What does this guy want? What does he want? He just wants this. I guess we can just paste it here. Boom. So context is going to be void. LHS is point pair. And RHS is point pair. And now we have to double check if this comes in like ascending or descending order, because we need to reverse it if we want like the smallest distance to be at the end of the vector. So PDQ sorts in ascending order. So the 0th element will be the smallest one, so we need to reverse this. So we want to do RHS.distance is less than LHS.distance. And we'll just note, well, we'll call this greater than. And then this will make sense. And then we'll just pass in greater than as our function here. And so that will make it clear that we're like going in backwards order. Okay. Does this fail? Nope. So now we should be able to return a thing, which should have points as points, and clusters as clusters, and distances is distances. Wow, simple. Simple. And maybe this works. Maybe it doesn't. I don't know. Okay, so let's at least try creating our thing. So here we'll say our clusterer is going to be an agglomerative clusterer. And I guess we just make it here. So this gets a little tricky because he's storing a reference to clusters and a reference to points, but we have that same problem where we're allocating them here on the stack and then moving them over here. So how do we want to handle this? Points is fine because it's an array list and the array list is pointed to the heap. We can just do the same thing where we stick clusters on the heap here. Alloc dot const var clusters is equal to alloc dot create clusters. Error defer clusters or alloc destroy clusters. Clusters is equal to initialized thing, which means that now we can create our agglomerative clusterer. Initialize with our allocator, points, items, and clusters. And we have to be careful here because if we ever resize our points array, then we have to remake this guy, but I don't think that's not a problem right now. And we can just do this. Clusterer is equal to clusterer. And then I think we're chilling, maybe. Maybe. We actually should error defer points.init as well. The fact that we can do that is fucking trolling. And then here on dinit, we also have to say self alloc destroy self clusters. And probably, does this guy have any like heap allocation on him? He does, right? He does. So this guy needs a dinit function. And he needs to call dinit on the points. Self distances dinit. Here we go. Okay. I don't know if we got everything. Cluster.dinit. And probably this guy needs to come first. Yeah, something like that. Sure, something like this. And then that means we actually have to stash the allocator in here as well. Uh-huh. Alright. Unused function parameter. That makes sense. Just kind of stub that guy out. No function named dinit on points, really? dinit, of course. Cannot dereference non-pointer type. Sure, 162. So this guy needs to be try on the allocator. Error is ignored. And expected type. This found some error union on clusterer. So probably this guy needs to hit a little, smack a little try on here. And then at 26, try here as well. Okay. So address and use error. So kill that, restart it. And at the very least, it looks like we're up and running. And our memory usage is not through the roof, which is good. So now we just need to do like something where we iterate. So first, let's not create these clusters. And then over here, we have to add a cluster for every point. So here we'll just say clusters, add cluster. So const cluster ID equal this. And then we say clusters add to cluster, cluster ID I. Yeah. Yep. Which kind of, we also need an error defer on here. Dude, I'm sure that I've got memory leaks fucking everywhere. I have to get better at this. I've been in like RAI land too long, you know? Okay, so probably now when I refresh, we see no points. We do see points though, which means that I've done something wrong. Oh no, we should see, no, we should see points. Every single cluster, every single point is in its own cluster. That's right. That's what we expect to see right now. So here, if we look at our response, we see our clusters. We have a bunch of clusters with a single point. Great. Okay, so now let's implement the next function. So let's add a little button. Let's start with the front end. So let's do in index HTML, let's add a little button here. So let's say, is there a button type? Which one am I supposed to use? HTML button. Okay, sure. Button, next. And this is gonna have some ID, next. And then we go to JavaScript. Daddy Compiler isn't looking after me anymore. Yeah, I like Daddy Compiler. No. Okay, so we need to like get the button. This stuff is going to have to move into its own function. So we'll call this like re-render. Function re-render, like this, I think. Dude. Async re-render, async function re-render. Yeah. We get all this stuff, and then here we just call re-render. And then I refresh just to make sure everything's still good. Nice. Okay. So now we are going to say that we on load, we look for the next button. So this is document get element by ID, but next. And next button next button on click equals next. Async function next. All right. So he is going to create some sort of fetch thing. He's going to try to write to some like next button. Let's just do this. He'll just write a get to next. I know it's not right. You're supposed to like put when you're trying to change state. Shut the fuck up. I don't care. You know? We're just going to call it get on next, and then we are just going to re-render. There we go. The simplest thing we could possibly do. And then down here, we'll just say, hey, we have a new thing now, next. And he has some purpose. And his purpose is to iterate. Right? And so down here, we'll say, hey, we have a new URL purpose. It's a next. Next. Which means that whoever fucking calls a switch on this thing is going to get mad now. He's going to say, hey, we need to do something if somebody starts to call next on us. And that's just going to be simple. We're going to do a app next. Yeah. Sure. Why not? Which means our app needs to have a fucking next function. So here we'll say pub function next. This is probably going to be try. And here we'll say self dot clusterer next. It's all so easy. I wonder if that's good enough. Problems. Oh, because actually this stuff just wasn't getting compiled before, so now we're going to actually see all the problems with it. So this actually thinks he can't fail. Oh, so maybe it's just fine. Maybe it's just fine. Okay, so now what? Expected error union type found void. Do not save. Hello? What the fuck is going on? 192. Oh, I just didn't remove the try because I am an idiot. No field member len. Oh. Oops. Here, I'm supposed to just write without the thing. Let's do this. Zig build down here, and then we can look at 78. So he doesn't like this because these guys might not return. So for now, we're just gonna let it roll, right? We're just gonna try to unwrap them as optionals, and if they don't, we'll crash. But we should always have a valid thing here. Error is ignored. Oh, which kind of means that here, this guy will return an error. Which means that over here, he will return an error. Which means I was right to begin with. Expected error union type found void. Because I didn't save. Okay, it looks like we're running. And if I hit next, let's see what happens. Next. Oh. When I hit next, he didn't refresh. Also, there's an error that gets propagated up here. Panic, attempt to use null value. Okay, so lots of problems. Let's start with the fact that our index JavaScript... Oh, he does call re-render. Okay, let's look again. Okay, so address in use. There's a way for me to just ignore that error. Which I thought I was doing already, but I must have lost it when I updated. So in our server on initialization, here when I listen, I have to say, hey, I know that when we crash, I know that, you know, you're going to get mad when we crash. Because when we crash, our socket doesn't get closed immediately. The kernel kind of like leaves it open. But look, just let me have my way. I think it's actually reuse port, which is the problematic one. So if I say this, I think that now this bug goes away. Now we can refresh here. Okay, so when I click next, next is called, but then he never returns, which is kind of interesting. So what's going on there? So either we're getting stuck in infinite loops in next, or we're erroring out and we're not logging it. Both of those things are very possible. So let's look at our server, and there's like, I'm pretty sure that there's like an empty catch in here. So let's just, for now, do a little error handling request, right? We're not gonna get crazy. We'll just note that there was an error, and then see if that's causing the problem. So it looks more like we're just fucking stuck. So let's do this. GDB. args. Run. Refresh. Next. Breakpoint. Okay, so he's just kind of sitting there doing nothing. Why is he complaining then? Why isn't he returning then? Oh, probably because when I do this, I still have to send a response. Where kind of everybody else returns to the caller. So here we have to say, just request send response, maybe? Respond. And can I just say, I'm fucking done? What are my response options? Are they all sane? Keep alive, true. I want that one off. But otherwise, I think we're good. Expected to content. So here I say nothing. You know, we didn't do anything, but here you go. Oh, oops, I'm still running on GB. I don't need to do that anymore. Run, next. Okay. So, oh, we're re-randomizing the points on every single refresh, which is fucking stupid. Where is that happening? Reroll points. Where is this happening? We don't want to do this every time anymore. So now we want to see some form of progress. Refresh. Next. Okay, so we are getting points back, and we can look at the response, and we can see if our clusters are growing. And we do see that there are some clusters in here that have 2 items, which is good. And so can we, like, slap the button a few more times? And let's see. One, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. Yeah, we are getting a lot of empty clusters, which is a good sign. We crash sometimes if we click too much. So here we try to say, hey, is there a cluster for this point? And he's saying no, which is kind of a surprise because we're supposed to be populating all of we should never end up with a cluster without the value. So what the fuck is going on there? What the fuck is going on there? So we say on our next function, hey, is there a cluster containing point B? Is there one containing point A? And if they are, we merge them. That's it. Simple. So this guy's saying, no, there's not. So I walked every single cluster and I didn't find your thing, which means that here we must not have merged them correctly. But here we did say, hey, for every element in B, stick it in A. So like, what the fuck is going on? You know? You know? Ugh. Okay, I don't see anything like majorly obviously wrong. We could just start logging. So, stood debug print merging clusters this and this. we'll probably want to log the point pair too. All right. Refresh, next. So we merged clusters 94 and 60. So now if we look at the response here, we should see 94 is 94 and 60 is empty. Okay. Chilling there. So next, merging 94 and 94. Oh, I could see a bug there. Yeah, okay, that's the bug. That's the bug. So what happens is we try to merge the same cluster into itself. We take all of the items from B and we stick them in A, which is the same. So we just take all the items and we append them to the same thing, bug, and then we just rip the whole thing out. So here we have to say if A ID is equal to B ID, fuck off. Simple little bug. Okay. So now if I slap this next button a few more times, it doesn't look like we're like crashing anymore. And we do start to see like areas that are the same color, which is good. Let's just keep going until we get down to a small amount of clusters. Next. Let's do a few more. Can we look at the pretty picture as we go now? Does anything do we see anything happening? I actually don't see anything happening, and I suspect it's because we have to clear the canvas. I would like to see some color change, you know? So probably here if you do like a ctx.clear reset. Probably canvas context HTML. Let's just see reset. No. Oh my god, let me reset. Resets the rendering context to its default state, allowing it to be used to draw something else. No, I kind of want just fucking make it white. Do I have to use clear rect? Erases the pixels in a rectangular area by sending it black. I guess I just have to clear rect the whole fucking thing. Clear full oh yeah, it's you can see it right here. All right, let's try that. Refresh. Zig, build, and run it. Refresh. Okay. So let's see if we see any color change. I am seeing color changes around here, which is good. One color change there. It's hard because we only have 3 colors. What we could do is we could make a gradient. Instead of doing colors. Oopsies. I should gotta go to the habit of killing this guy. Instead of doing raw colors like this, I wonder if we could do something that's function compute color for a given cluster ID. And then we could return an RGB string. So it would be RGB this plus something. And can we just kind of continuously go from red to green? So we can do plus. We know that there's gonna be 100 points, but maybe we even take in num clusters here, right? And then we can say cluster ID over num clusters, and just hope to God that JavaScript is gonna convert this to a float for me. So const normalized normalized ID, I guess we'll call it. Rotate around the HSV color space. That would be better, but I don't know how to do that right now. But I guess it would just be hue. I would just change hue, HSV, right? Because I probably want just saturation value, just be fucking max the fuck out. Herpes simplex virus. Do we have it? Who knows? Herpes in all caps, nice. HSV color. Can I do HSV as canvas color HTML? I don't really know if that's I'm assuming that I can just type HSV instead of RGB in there, but I don't actually know. Fill style color, CSS color value. Here we go. This is what I'm looking for. And I'm assuming that CSS color values let me do RGBA, HSLA. I guess HSLA is closest to is the same thing. So here I just do this and I just rotate around H here. Yeah. So here we want 1.0 for opacity. Here we want 100%, 100%. And then we just say, I assume that this is like between 0 and 360 based off of this. Because 120 is about halfway. That seems reasonable. It's not about halfway. I just fucking lied. But I'm going to assume 360 anyways. So here we'll say Q is this times 360. And then we can just do HSLA this plus Q plus this. And now we can say compute color cluster ID. And here we should just, is there like assert in this language? I guess it's just if cluster ID is less than greater than or equal to greater than num clusters, probably greater than or equal to. So because then technically this should be num colors minus 1 because we shouldn't ever have an index at the max distance. Then we should throw. How do you what? Is there an exception type that I'm supposed to inherit from? Throw in JavaScript. God, I feel so fucking stupid when I get into this language. Throw new error. Invalid cluster ID. There we go. And then down here, we will just say colors equal to compute color with cluster ID and data clusters length. There we go. All right, let's see what happens. Let's see what happens. Nothing good, that's for sure. Console logs are going to be annoying, so let's just yoink that out of the way. Okay. Let's maybe print it before we do it. Const ret is equal to this. Console log ret. And then return ret. Seems fine to me. Maybe these decimals are no good. Do I want to do like int? I don't know if that's like a, maybe we floor. And then the decimals go away, maybe? Yeah. Still doesn't like it though. Could be that I misjudged what these are. Light green, dark green, pastel green. So I guess maybe I want like, can I just HSL color picker? So this is hue, saturation. L should be, I guess, more like 50%. Oh, that's probably what it is. I probably have this at 100%, and then everything's rendering as white. Yeah, there we go. Nice. Sick. Sick. Okay. Oh, yeah, that's actually kind of... Look at that. That's kind of nifty. So we start to see people kind of merge. Yeah, okay. Nice. It looks like it's kind of working. We should add like a step size. This is fucking stupid. So, maybe we say, what? Input type equals number. And ID is equal to step size. And when we say label for step size, and then we say step size this. Is that how you fucking... There you go, yep. And I guess we need to set its default value to 1. Nice. Okay, and then we can set this to 5, and then we'll just say that when we call next, we say for let I equals 0, I is less than num steps, and I++. This is stupid, but it's okay. It doesn't fucking matter. And I guess here we need to get num steps from the button. So document, or from the input. Get element by ID step size. And then probably value. I don't actually know, but we're guessing. Yeah, that looks like it. So let's do like 50 steps, and then everything should be one color. No? Why not? Oh, because we might be we have to go through n squared space here. So a lot of times just nothing's gonna happen. Right. So what we should do is we should change our app. Why did I close the fucking browser? Oh, it's so annoying. I should have done that. What we should do here is when we go next, we'll just say, we'll do this in a loop, right? And if the clusters are the same, we will just move on. Yeah. And let's go back to local host 999. And so now if we go, 98, we should end up with 2 clusters. 1 cluster. Interesting. Let's see what came out of this. Is it because my color picker is stupid? Whoa, what just happened? How come when I refreshed it changed? Oh, it's probably because I'm running 2 servers at the same time. It sure is. That'll do it. It's just like fucking guessing which one. So here I did end up with everything in 1 cluster immediately, which is kind of surprising. I wouldn't have expected that. Let's add a reset button so that I don't have to restart the server every time. So in here, we'll just do a little reset goes to reset goes to reset goes to reset. And in here we do the same shit. Bump bump. And here we just call re-roll points, and then in re-roll points we have to regenerate. We have to reset the clusters and the agglomerative clusterer. So here we do this with our alligator. I guess we should D into the old one first. And the same thing for the clusterer. Right, like all this, boom, 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 and self.clusterer D in it. There we go. I think that's cool. Let's try that. So now we go into our HTML and we add a little reset. And we go into our JavaScript and we add a little reset. And this just calls reset. And I guess then he has to re-render as well. And now we have a reset button is reset, and this is reset. Boom, oopsies. So refresh, reset, 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 nice. And then if I say, let's go 50 steps, reset. Okay, so that's working, but I don't really understand why, like, my step size. Oh, it's probably just because I don't break out. I'm probably just going to the end every fucking time, like an idiot. I probably just forgot to break the loop. Oops. Oops, 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 oops. Let's try that again. Okay, so now if I go 50 steps. Okay, that looks way more reasonable. So if I go 98 steps, we should see, like, from the start, we see 2 clusters. Nice. Nice. And if I go, like, 90 steps, Not bad. Not bad at all. I'm happy with that. That's pretty cool. Pretty cool. Okay, so now I think like the next sane thing to do is probably to actually group these guys, right? Because like this is silly to have like uniform distribution and then try to cluster those. Really, we should have like some sort of like points of higher density. So let's do that. Let's do that. So I guess just when we generate our points, we kind of want to probably take in like a target cluster value, right? We're gonna maybe we pick 3 positions and then we push like a Gaussian distribution around that area or something. I think that probably makes sense. I think that makes sense. Yeah. There's a bug in here, by the way. If we've like, there's something about like idempotent operations, right? So here it's like we deinitialize the cluster, and then we might like fail to create the agglomerative clusterer after this, and then we'll be in a bad state. We need to make sure that we stay in a good state no matter what. So you're supposed to do something like create the new ones first without binding them to self, and then assign them after or something, but I'm not going to deal with that right now. Not going to deal with it. Okay, so here let's set up generate points, take in like target like num clusters. Okay. And then we'll kind of go in batches. So if we say like items len over num clusters, we're going to have less than 100 points. So sorry, 100. So if this is 100 and this is like 3, we're going to have like 1 remainder. So we'll say num buckets is this, and then we have to take the remainder and iterate add 1 more to each bucket if we're less than remainder. I'm pretty sure that's how it works. Pretty sure. Otherwise we won't end up with the number of points that we asked for. Okay. So how do we handle this? How do we handle this? I guess we say for bucket in num buckets. I guess probably we don't actually care about this number at all. We'll say maybe we'll count how many buckets we've looked at. Oh, we do care. We care. Bucket ID. If bucket ID is less than remainder, less than or less than or equal to? If I have remainder 1, then it's less than. Then we only do this on bucket 0. Then we add 1 to like the number of elements. So here we'll say const num or var bucket elements equals num elements for bucket, and here if we have or below render, we say bucket elements plus equals 1. I think. Not really sure, but maybe. And then what? We say var item ID starts at 0. And then we say for 0 to bucket elements, we do something with the item ID. So we do this. Boom, 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 boom. const item is equal to points item ID, like this, I think. Items item ID. And then here we're gonna have to like, we're gonna want to like center these around something. For now, let's just do it around. Okay, so we'll say that our x and y values, we're only gonna randomize them in the range like 0 to 50 instead of 0 to 100. And then we are going to add them to some offset. So we'll just put them somewhere. Maybe we'll do this. We'll say bucket center is going to be something in the range of 25 to 75. That way, and then this can be in negative 25 to 25 for both of these. And then we can just add these to bucket center X and Y. This is like pretty crude, but I think this will do what I want. And then here we need to item ID plus equals 1. I think that'll do it. So let's say that we wanted to generate with 3 clusters. I think that this will, oopsies, eventually we'll parameterize this, but for now let's just do this. Comp time int, so var item ID. So this has to be assigned as like, hey, we're a U size, and we fucking know it. Okay. So does that look clustered to you? It doesn't to me, but maybe because the range is too big. So maybe we'll do maybe we'll do like negative 5 to 5. Let's just see how that feels. Weirdly not very clustered. So what are we doing wrong here? Oh, it's because we're still doing the old way underneath and just resetting all the work we just did. Derp derp. Reset. Okay, let's get crazy. And start with really fucking tight. There are clumps, but it does feel like it's not 3 clumps. Oh, it's because I'm an idiot. This should be 0 to num clusters. That should give me 3. There we go. That's 3 segments. Okay, and now we'll go back up to saying, hey, we can go from negative 25 to 25 here. No? Something about this is wrong. Let's look at the thing. Is this hierarchical? The clustering algorithm is, but we're a little stuck. So here we're only going up from 0 to 9, so we're doing something wrong here. Bucket elements is num items for buckets. This should be over num clusters. So num buckets is just like a stupid thing. So, okay, so we say, hey, this is our remainder. This is our number of elements per bucket. Seems right. Okay. Points. We do have 99 points, and a bitch ain't one. Let's log the center points. I'm not really convinced that these are reasonable. Center point. Are you using VimWiki for the to-do list? This is just a text file. Or I guess technically a markdown file. I don't know what VimWiki is. Sounds fancy. Bucket center X, bucket center Y. So it could just be that with like the buckets like with 3 buckets, the chances of them hitting each other are pretty high. So yeah, 67, 43. Okay, so let's make more buckets, and then they'll kind of like end up kind of looking. Hopefully, then we'll get spaced out a little bit, just in case like 2 buckets overlap. I don't like that either. Maybe we'll reduce the variance within a bucket. And these should all get parameterized later, but for now, we just hard code and hope for the best. Oh, there we go. Okay, yeah, nice. That feels pretty good. And then I'll just increase the number of buckets again to go up to like, from 3 to like, maybe like 7. There we go. That's like getting some pretty clear clumps. And now we can start saying like, okay, what if we go 5 steps at a time? We do start seeing the guys that are all close together, really close together, starting to like take on a single color. Oh yeah, let's go, baby. I don't like this color flipping. What I want to do is when we merge clusters, I want to take the bigger one. So if A items len is greater than B items len, we'll just swap them. Or if it's less than, it doesn't really matter. Oh, we're appending to A. So if A items length is smaller, we swap them. A equals B, const temp is equal to A, B equals A. Temp. Oops. So what that should do is should make sure that we don't end up swapping cannot assign to constant. Right, var. That should make sure that the bigger one is the one who always wins. Okay, so. There we go. Yeah, there we go. Okay. I'm pretty... Oh, baby. Okay, so green's going to take over here. Yeah, nice. Nice! We did it! We did it! So I think we spent a lot more time there in, like, Ziggisms and, like, allocation and stuff than I would have wanted. Not that much time on, like, actual hierarchical... What is it called? Hierarchical clustering. But at the very least, I think that like the reason I started with hierarchical clustering was I did think that it was kind of like the simplest case and gave us like an opportunity to like build out the API and stuff. So pretty happy with that. Probably we'll be back tomorrow with an attempt at a different type. So ones on the list are, I wanted to look at AP clustering, affinity propagation clustering. I wanted to look at k-means clustering. And I wanted to look at DB scan. I wanted to look at all of these. So affinity propagation uses this like match matrix thing that I don't really understand. This one's like, it's like, I don't really understand what this thing's doing. K-means clustering is just like you pick some sample points and you kind of like nudge them towards centroids of masses. I don't really understand fully how they get like pushed away from each other, but we'll see. And then DB scan, that's something about like density based. So they do something like you set some like minimum density, maximum density, minimum density, and you start like building up clusters by density in some way. Not really sure that one either. So we'll take a look. Thanks for watching, guys. If you like what you saw, we stream most days at around 1 or 2 o'clock Pacific time. Sorry, no, not at around 1 or 2 o'clock. That was old me. New me streams only at 2 o'clock Pacific time for 2 hours. So it's 4 o'clock now. So if you're online live, 2 hours ago is when I would have started. There's a YouTube link and a GitHub link in the Twitch description where code and VODs go up. There's like a bunch of like previous shit in there. So like things like 3D game engine, really shitty for like the intro screen. Things like Rust operating system, virtual file system, visualizer for like diff algorithm, there's a bunch of other shit in there. Terminal emulator, but I don't remember it all. So if you want to go take a look, that's all in there. Do I like Zig? I think so. I think that it's like, I would use it over C and C++, which is something. I would recommend it at work at a C++ shop. That's something, once it's more stable. So I feel good about it, because it's like, the thing is like, I have to do like some like performance metrics investigation and stuff, but like it feels to me just like it's not doing anything crazy and doing sane safety checks. It's just like you've got like your C style, don't be fucking stupid, right? C++ just pisses me the fuck off when I use it. I was just so fucking mad. Because it's just like it's just like you have things like you call like the standard library function stood async, and it's just not async, and you're just like, that's fucking stupid. And then like it returns a future, and every future usually you can just drop them, but when you have specifically one returned by stood async, if you drop that future it blocks, and it's like, that's fucking weird. You know, it's just like lots of like little things like that. You have like stood remove, and that doesn't actually remove anything. It just invalidates elements at the end of your container. And it's like, I get it, I understand why, but it's like, fuck off. Stood move isn't a move, right? It's just tons of little things. So C++ pisses me off. Zig, it's like, it's not doing anything enough that it could piss you off, right? It's just like, here's the language in the same way C is, but it's got like niceties on top of C that make it worthwhile. Rust is probably still my baby, but I would never try to push it on other people, just like I would never try to push Vim or Tmux or Nix on other people, but I use all of those things. So, you know, it's sitting in a pretty good spot. I have to try Go at some point, because I bet you there's a really good chance that like anywhere where I'm using C++ at work, I don't actually have to be, and that might be causing extra issues. Not really sure. I'd have to think about it. Yeah, did I plug everything? I plugged my shit. Got distracted. I think I'm gonna call it there. Thanks, guys, and I'll catch you on the next one. Bye.